Good evening, everybody. I've talked to a couple of you guys individually already, but if I haven't met you tonight, I'm Rusty Weneck. I'm one of the practice managers here with Cardinal Solutions, and I'm going to give you guys a very shallow dive into getting started with Arduino. I don't know about you guys, but whenever I'm starting into a new project, I find there's a lot of FUD out on the internet. I don't really know where to start and then where to go from there. So I'm kind of hoping that this will give you a starting point and maybe a vector of where to take off to. So before we start talking about Arduinos, we got to talk about microcontrollers. Microcontroller is basically just a little computer. It's got CPU, it's got RAM, it's got ROM, and a couple of inputs and outputs. In my hands here, I have an ATI Mega 328. It's a pretty common microcontroller. It's what's in a lot of the Arduinos. This happens to be the DIP packaging. And for a long time, in order to write programs for a microcontroller, you had to have a microcontroller programmer. So it fits into here. You have to write some C code and flash it. It's kind of got a bit of a barrier to entry, and that's what Arduino really attempts to solve. So Arduino is a convenience interface around the microcontroller. It has a hardware convenience interface, which is the Arduino board itself. Here you can see the ATI Mega. That's probably a 168 chip with the convenience headers for the input and output pins, voltage in and out, and analog in and out. It also has all the things you need for voltage regulation for the supply voltage. You can send up to about 13 volts to this and it'll be safe. They run on normally 5 volts, so there's voltage regulators on board. There's clocks on board to set the clock speed up. Pretty much all the things that you would normally have to put in circuit with these is on the board. The other side of the equation is the software side. So Arduino has a set of software that it provides out on their website. You can download that. And it has standard headers for a lot of their boards that defines those input and output pins. And it has 2 functions that it provides for you, a setup function and then a loop function. So you don't have to worry with getting all your C code set up, hooking that bootloader process, and then hooking into your actual program. You can see a lot of microcontrollers that come in 3 big form factors. Biggest one is the one I had in my hand, and that's the DIP form factor. For a lot of hobbyists, it's macro scale, so it's pretty easy to solder. Down from there, you have the surface mount form factor. You got to sometimes start to need some special tooling for that, reflow ovens, SMD rework stations, some things like that, and they are incredibly tiny. I have a board with a surface mount up here, and you can see just how small they are compared to the DIP form factor. Then they have some socketed form factors. But let's jump into a little bit of code. We love code here. And so the most simple example you can have is flashing an LED on and off. You can see we have our setup function and we got a loop function. First thing we're going to do is tell it to flash, set the mode of pin number 9, which is identified on the Arduino board as an output pin. And then once the setup function is completed, it will continuously run your loop function. So we're going to set that pin high, delay it for a second, set it low, delay it for a second, and then resume. So I have that one pre-flashed on this Arduino, and we're flashing an LED. It's as simple as that. Hopefully you guys can all see that. Not terribly exciting. So let's flash 2 LEDs. Have this program pre-defined here. We're going to turn one on for 3 seconds and then off for 3 seconds. We're going to turn the second one on for a second and then back off for a second. So this will actually give us kind of our first look into flashing the microcontroller. You can pre-compile this, or if you click this little arrow button in the Arduino software, it'll compile it, flash it up to the microcontroller. You can see pin 13 there flashing, and then it starts executing our program. Now, one thing to note with this is it's single-threaded. You can see as we're executing through here, top to bottom, turning one on and off for 3 seconds, turning the next one on and off for a second. If you want to handle multiple things simultaneously, you're gonna have to start thinking in terms of a scheduler of some sort. So I have another one here. I'm gonna cheat a little bit. I'm just gonna use millis off the system to get the number of seconds. I'm still gonna flash one LED for 3 seconds, and then I'm gonna flash the second one every second. So if we flash this and upload it to the controller. We now have two operations happening at the same time. You might notice where my cursor is down here at the bottom. Putting in a fake delay of half a second. Don't do this on the hardware interface, but where it comes in handy is on this nifty software provided by Autodesk, and it's called 123D Circuits. And they provide a library of components. So we got a breadboard, an LED, a current limiting resistor, and we got an Arduino on here. We can upload code to the Arduino. We can pick from different components and different output pins and run it all in the browser. So if you want to start playing around, as a hobbyist with what some of these tools can do for you, zero investment. Autodesk will also go on, it'll provide component sheets for you, it'll do PCB board layouts, and you can order custom printed PCB boards from them. Probably some cheaper places on the web to do them, but this is a great low-cost way to get in and to play around with some of these things. Unfortunately, because it's doing it all in memory, that loop function, it's going to execute that as fast as it possibly can. So I put in a fake delay in there just so it actually delays, and we get more of a real-time simulation than the simulation slowing down. If the simulation does slow down, it'll show you an elapsed time in the simulation, so you know that it's not really happening at the speed that you're observing it. Another good thing about this, you can actually go so far as to drop oscilloscopes in line. So this one's already running. This is a simple, doesn't even have an Arduino on it, 555 timer oscillator circuit. You can see it's flashing an LED on and off down here. Drop an oscilloscope on there so you can actually monitor some of those digital signals if you have something more complex, like a lot of times you will with an Arduino output. So a couple of years ago, I wrote a Cylon program. This was kind of the end result. Carved a pumpkin, set it on my front porch. This board here is what I revived the other night for purposes of this presentation. Embedded it in the pumpkin, took a 6-volt battery pack, drove the Arduino, put it in a Ziploc baggie, put it in the pumpkin, left it out on the front porch. In the nose, we have a passive IR receiver. We got the LED array up front, so it'll actually detect motion and then do some different things with the LEDs. So if we flash and upload this guy, there we go. So in general Cylon fashion, it'll start scanning left and right. When it detects motion, it will snap to a pulse width modulated pin on the Arduino. So the Arduino only provides 4 or 5 pulse width modulated pins. They don't all have that capability. Pulse width modulation, for those that don't know, is the ability to turn things off on and off very fast. So LEDs are binary. They're either on or they're off. If you undercurrent them, a lot of times they won't light up. But through persistence of motion, we can turn those on and off very fast and reduce the number of photons that are being emitted from them. And our eyes are only capable of observing up to about 60 frames a second. So if we're doing that 1,000 times a second, 5,000 times a second, depending on the clock speed, we can really dim those LEDs so that we can get some different brightness levels out of them. So it dims the LED, and then it goes on the hunt, searching really fast, and then eventually it'll go back to its normal procedure. So what's really neat about the Arduino landscape is they provide a lot of shields. A lot of times they have these more complex electronic components bundled up into almost like a Lego building brick. You can set them on top of the Arduino, on top of the header pins, and it'll provide sensor input, temperature, humidity, noise, the passive infrared. A lot of people are using them for robotics. And then they'll provide libraries for that. So what I have here, I was working on replacing a taillight on my motorcycle. They didn't have what I wanted available out there, so I was going to build my own. What I wanted it to do is when I applied the brakes, flash the lights on and off at a high rate to grab people's attention that I'm stopping so they don't hit me. I also wanted to embed the turn signals inside of the brake lights so I didn't have turn signals hanging off the back of the bike. Not quite there yet, but one of the cool things is I was able to get some TLC 5940s. These are LED drivers. They got a lot of cool features to them, including only having a single resistor as the current limiting resistor. Saves you some space on the board. But it there are libraries that people have written for that chip out there already that handles all the multiplexing for addressing each one of those using the serial output on the Arduino. So if I plug this guy in, let's dim these lights. Right now, I just have it dimming the brake lights from low to high and alternating the turn signals left and right and inversing the brightness on them, just to work out some of the addressing and brightness functions that the TLC 5940 provides. I doubt many people in this room have done multiplexing before, but it's kind of a complicated process, and this library, it's a C library include, makes it really easy. So you can just address the LED, set a brightness level. This chip provides 4096, that's its address space, levels of brightness for each one of these LEDs. And then at the very end, you just call TLC update, goes ahead and commits all those values out to the chips, and then the chips drive the current to the LEDs. So, like I said, very shallow dive, but what's neat about these is you have all the tools. You know, we all know how to code. Arduino makes it super simple to get into the hardware side of things. Sometimes you can do it all with a breadboard and a couple of jumpers. Maybe you want to go deeper and get a perf board and start wiring some things up. Really, it's just a matter of then having a good idea to justify the time it takes to get into it. So if you guys have any questions, I'll be around for a little bit. We do have another group coming here at 7, but you guys can hang around as late as you want. We got food and drinks in the break room, and all of our us presenters I think will hang around for a little bit too if you have any questions.